Basic derivatives, product rule, Leibniz notation. So, the way Leibniz does it is he has a function, and within this function, there are two functions multiplied together. Now that's when you need to use the product rule. So, this formula is essentially the first derivative of this formula. So, you have the derivative of y equals v multiplied by the derivative of u with respect to x plus u multiplied by the derivative of v with respect to x. X is just the variable in this example, but that's it. That's how you do the product rule his way. So the product rule, this is just a simple way of doing it. It's just, well, no, it's not doing it. This is just a simple example. X times x. That's just simple, very basic stuff to show you what, I guess, it looks like. So, I'll give you an example. Let's say y equals x to the power of 4 multiplied by x squared plus 1. So, that's a function here times another function, which is this in the brackets. So, because technically there's like a multiplication in the middle, but you don't have to write that. So, if we write the formula on the bottom, that's u times v. So we can sort of draw lines to indicate where these, if you have to, you can draw lines to indicate where they, if you're struggling, but otherwise, now, let's separate the page a bit and write down what u and v is for later. Okay, so now the product rule, when we're finding the derivative, is v multiplied by the derivative of u with respect to x plus u multiplied by the derivative of v with respect to x. So that means we need to find the derivative of u and we need to find the derivative of v. So under these, we'll find the derivative of u, which is 4x to the power of 3, and the derivative of v with respect to x is just 2x. So, if we sub that in, we get now you can rearrange that and simplify it, but I'm not going to. I'm just going to leave it there. I'm sure if you do it to this stage, whoever is marking it or whoever wants it a certain way will specify. So if you want to leave it at that step, you can go further, is what I'm saying. But that's it for this example. Next example, we'll have y equals x to the power of 3 plus 3 multiplied by x squared plus 2. So here again we still have two functions. So if we put the formula under it, or yeah, it's u multiplied by v, you can show that that's what they equal, but separate the page anyway and rewrite it. So u equals x to the power of 3 plus 3, and v equals x squared plus 2. Now the derivative of y with respect to x is, of this function, is v multiplied by the derivative of u with respect to x plus u multiplied by the derivative of v with respect to x. So we find the derivative of u and the derivative of v to fill in this equation. So derivative of u with respect to x is 3x to the power of 2. And the derivative of v with respect to x is 2x. So if we were to fill this in, the derivative of y with respect to x would be sub in v, and then we sub in du with respect to x, which is 3x squared plus u, which is x to the power of 3 plus 3, multiplied by dv with respect to x, well, the derivative of v with respect to x, which is 2x. Okay, so like I said before, you can go further, you can just put these at the front if you want to, but otherwise I'm going to leave it like that. Do another example. What was that? Yeah, make it example 2. Well, it's the third one today, but yep. So, of y equals x to the power of 4 plus 8x minus 5 multiplied by 2x to the power of 3 plus 5x. Now, those are the two functions. And now, if you want to rewrite it, u multiplied by v, signify which is which, but again, write it over in the corner. U equals x to the power of 4 plus 8x, take 5, running out of room here, and we'll have v equals 2x to the power of 3 plus 5x. So, the derivative of y with respect to x from the product rule is v multiplied by derivative of u with respect to x plus u multiplied by the derivative of v with respect to x. So now we need to find the derivative of u and the derivative of v. So that'd be 4x to the power of 3 plus 8, and the derivative of v would be 6x to the power of 2 plus 5. So to sub that in, 2x to the power of 3 plus 5x multiplied by 4x to the power of 3 plus 8 plus x to the power of 4 plus 8 x take 5 multiplied by 6x to the power of 2 plus 5. And that there is your first derivative of this function up here. Thank you.